Hello geometry students, welcome to notes 11-5, Trapezoid and Kites. Let's get started. We got trapezoid properties first. If you want to pause the video, copy this down, come back to it. I'm also going to scroll up here. If you want to copy this down, here are my examples. You can copy that down so that while I'm going through this, you have to pause it intermittently. Do it all now. All right? First thing, we're going to go through our properties first. We know in a trapezoid we have one pair of opposite sides, which would be the bases. So the opposite sides are parallel. That would be the opposite bases here. Those are going to be parallel to each other. In an isosceles trapezoid only, we have one pair of legs, the sides, which are congruent. We have the diagonals, which are congruent. And we have base angles, which are congruent. That's only for an isosceles trapezoid. So a lot of congruency going on there. All right, with every trapezoid, all of our trapezoids that we have, the mid-segment is the segment in the middle here. So in my trapezoid here, AE is the mid-segment. We can find that mid-segment by using this. It's going to be equal to half of the base 1 plus base 2. If you think about a triangle, if we have the bottom of a triangle, the mid-segment of the triangle is half of just the bottom of the triangle, the base. Well, in a trapezoid, I've got two bases, so I have to add those bases together and take out half of that. So it's very similar to the triangle one. In this case, we have two bases instead of just one. Quick example of that, if I've got a trapezoid, I'm going to draw one over here. If I have a trapezoid, I need to find the mid-segment. Let's see, 6 on top and 15 on the bottom. All right, add them both together, get 21. 21 divided by 2, or half of 21, is 10.5. That's the mid-segment. Sometimes they might actually give you something like this. They'll say the mid-segment's 13, and the base is going to be 18. What's the other base up there? In that case, just find out what number is 13 in the middle of. You've got 18 here, and it's easy to think, okay, from 18 to 13, I go 5. So I'm going to go 5 again to go from 13, subtract 5, so I get 8. So 13 is right in the middle of 8 and 18. Okay, so that's all we have for our trapezoid. First example then, if RM is 2x up top, if AE is 25, and then CL is 5x plus 1. Find the length of each base, the top and bottom here. Well, I need to solve for x, and I know that from this formula here, more or less a formula, I'm going to put a cloud around it because it's important, we'll use it. All right, we're going to say the mid-segment is half of both the bases added together. So I can say that 25 is equal to half of 2x plus the 5x plus 1. All right, I need to solve for x. Combine like terms inside the parentheses, I'll get 7x plus 1. All right, and some of you guys might want to distribute that 1/2 to everything inside, but you could also cancel out the 1/2. If I multiply the whole entire thing by 2, it's going to get rid of that 1/2. It's kind of cool here. So if I multiply the whole entire equation by 2, 25 times 2 is 50. And then if I get 1/2 times 2 is 1. So I just have 7x plus 1. That's an easier way, I think, algebraically to do this. Subtract 1 to the other side, so I have 49 equals 7x. Divide by 7, so x is equal to 7. I can plug that back in to find the base, so 2 times 7 is 14. 5 times 7 is 35, plus 1 is 36. So if I would add together 14 and 36, I get 50. Half of 50 is 25, so I know I solved that one correct. All right, next one, it's going to say the measure of angle C is given to me 80 degrees. All right, I've got the measure of angle M is 145. Find the rest of the angles. In a trapezoid, these two sides are parallel to each other. And also I have that mid-segment, which will be parallel to it as well. If I'm just looking at angle C and angle R, these are like I've got parallel lines cut by transversal. They're same side interior angles. Oops, sorry. There we go. They are same side interior angles, and I know that they are going to be supplementary. So if this is 80, up here is going to be 100. Also, angle C here and the top of angle A are going to be parallel lines cut by transversal. I have corresponding angles, so they're going to be the exact same. 80 there, 80 there. And up top here, if that was 100, this is going to be 100 as well. We see that's correct because I had a straight line, so 180 add up to 180. Same thing over here. If I have 145 at M, corresponding to that, the exact same angle would be right at the bottom there of E, 145. And then I could say that I've got supplementary angles there, so subtract the 145 from 180 to get 35. And that 35 would be corresponding down here as well. Again, the 145 and the 35 are same side interior angles, they add to 180. So I found all the angles. Next, we have kite properties. So here are our kite properties. You want to pause this, copy this down. I'll pause it again when I get to the examples. For a kite, I have no sides parallel. So most of our quadrilaterals, we've had sides parallel. Not for a kite. We have two pairs of adjacent sides that are congruent. That would be AB and AD, and then BC and DC. And then I have one pair of opposite angles which are congruent as well. So in that kite, it's going to be angle B and angle D. The whole entire thing of angle B and angle D are congruent. Diagonals are not congruent, but the diagonals are perpendicular. So they form a right angle. One diagonal is bisected. It's cut in half. So BD right here is the one that's bisected clearly. And lastly, the diagonal bisects one pair of opposite angles. So that's a lot of stuff for kites. We can put that on there as well. The opposite angles here are now bisected. All right, everything we have about a kite. So let's do our examples. First, if AB, well here, let me give you all the examples. You can pause this, copy those down. First, if AB is equal to 10, AE is equal to 6, and EC is equal to 18. So let's find the length of each diagonal and the perimeter of the kite. So I want to find the length of one diagonal AC, the diagonal BD, and the perimeter of the kite. Okay, well I see 10 is up top, and so it's going to be 10 down here as well. That'll help me with the perimeter. I need to find the length of then AC, just add the 6 and the 18 together to get 24. And then I can find the length of BD looking at this triangle inside there. Notice it's a right triangle. And so if I have the hypotenuse is 10, one leg is 6, you should know now by now that this other leg is 8. It's a 6, 8, 10 triangle. So 8 and 8. 8 and 8 is 16. Now I need to find the perimeter of the whole thing. Well, I know I have 10 and 10. I need to find out DC and BC. They're both going to be the same thing. Take a look, I've got 8 and 18 in this right triangle as well. This is a right angle, so this will also be a right angle. Okay, so I need to use Pythagorean theorem to find side C there. So if I have 8 squared plus 18 squared, that's going to be equal to C squared. 8 squared plus 18 squared is 388. And then take the square root of both sides. So C is approximately, I'm going to round to the nearest tenth, 19.7. So 19.7 there, 19.7 there. So the perimeter is 10 plus 10 plus 19.7 plus 19.7. Add all that together, you'll get 59.4 for the perimeter of my kite. Last example, it says the angle ABE is 40 degrees. So ABE is 40 degrees. And then angle BDC is 70 degrees. So from B to D to C is 70 degrees. Find the rest of the angles. Well, if I can see here, angle B and angle D are the whole things are the same. They're congruent. So if this part's 40 up top here, the bottom part will be 40 as well. 70 degrees here, it'll be 70 up top. That was easy. Now I have 90 degrees in the middle, so I can just take a look at each one of these triangles and just find the third angle there. So 40 and 90 are going to add up to 130, so there's 50 left over. And that angle was bisected. It's the same thing on both. Makes it easy again. I have 70 and 90. That's going to add up to 160. So I've got 20 more left over for this angle out here. 20 and 20 to make that simple. All right? So we had trapezoids, we had kites. Make sure you get those properties, the examples, bring them to class. We'll get started. Thanks, guys. Have a great day.